Under the theory of repulsion field, how is the development of earthquakes, volcanoes, El Nino, and La Niña explained? It is believed that the repulsion field produced by the sun, or the solar repulsion field, in other words, takes part in the development of the natural events such as earthquakes, volcanoes, El Nino, and La Niña. Under the theory of repulsion field, it is believed that if poor neutron matter, the matter that is made of 118 chemical elements and is found everywhere on the Earth, is put in conditions of extremely high temperature and pressure, like those at the centers of stars and even the center of the Earth, such poor neutron matter will convert into rich neutron matter. And the reverse also holds true. If pressure and temperature of a rich neutron matter body is lowered, such rich neutron matter will convert back into poor neutron matter. The conversion from rich neutron matter to poor neutron matter releases massive amount of energy. This is the way that the sun and other stars generate energy. More specifically, there is a continuous back and forth conversion between rich neutron matter and poor neutron matter at the cores of all shining stars like the sun. This massive amount of energy generated by the conversion from rich neutron matter into poor neutron matter, in turn, makes the stars shine. In any case, rich neutron matter always acts as an explosive. This special explosive will explode and release massive amount of energy if its surrounding pressure reduces fast enough. The second important point of the theory of repulsion field is that bodies of rich neutron matter produces repulsion field in the surroundings, and this repulsion field in turn repel the surrounding bodies of rich neutron matter. The repulsion field is similar to the gravitational field in its nature, but it works against the gravitational field. Gravitational field is produced by poor neutron matter, and it attracts the surrounding bodies of poor neutron matter. Meanwhile, repulsion field is produced by bodies of rich neutron matter, and it repels the surrounding bodies of rich neutron matter. Gravitational field does not interact with bodies of rich neutron matter. Meanwhile, repulsion field does not interact with bodies of poor neutron matter. This video clip describes how the solar repulsion field, produced by the body of solar-rich neutron matter, repels the body of terrestrial-rich neutron matter. The repulsion force exerted by the solar repulsion field on the body of terrestrial-rich neutron matter shifts the center of the body of terrestrial-rich neutron matter to the night side of the Earth. The third point of the theory of the repulsion field is that the bigger the heavenly body is, the higher the percentage of rich neutron matter it contains. So, it is believed that supergiant heavenly bodies like black holes contain a large percentage of rich neutron matter at their cores. Medium heavenly bodies like stars contain a smaller percentage of rich neutron matter at their cores. And small heavenly bodies like planets, for example, the Earth, contain a very small percentage of rich neutron matter at their cores. In other words, the Earth contains a very small amount of rich neutron matter, which is called body of terrestrial rich neutron matter, at its core, but the amount of rich neutron matter at the core of the Sun, which is called body of solar rich neutron matter, is much more considerable. Because the mass of the body of solar rich neutron matter is much more considerable, the Sun produces a quite strong repulsion field around the Sun, which is called solar repulsion field. The solar repulsion field does not interact with poor neutron matter on the Earth, but it repels the body of terrestrial-rich neutron matter and shifts the center of the body of terrestrial-rich neutron matter to the night side of the Earth. So how does the solar repulsion field take part in the development of volcanoes, earthquakes, El Nino, and La Niña on the Earth? This question is answered in more detail as follows. Without the solar repulsion field, the body of terrestrial-rich neutron matter at the core of the Earth would be completely a sphere. So, it would be impossible for the body of terrestrial-rich neutron matter to be, back and forth, converted into poor neutron matter. Therefore, the production of energy by the conversion from rich neutron matter to poor neutron matter does not occur. However, with the strong solar repulsion field, the body of terrestrial-rich neutron matter is shifted from the center of the Earth to the night side of the Earth. The combination of the following three factors, the shifted body of terrestrial rich neutron matter, the rotation of the Earth around its own axis, and the terrestrial repulsion field produced by the body of terrestrial rich neutron matter creates pieces of rich neutron matter shrapnel and drives these pieces of rich neutron matter shrapnel towards the lithosphere, the outer part of the Earth. As these pieces of rich neutron matter shrapnel come close to the lithosphere, pressure decreases. These pieces of rich neutron matter shrapnel convert back into poor neutron matter and releases massive amount of energy in the form of explosions, quickly raises magma pressure in the surroundings of the explosions. Because such explosions occur in confined spaces, magma pressure does not quickly decrease, but magma pressure remains high for a long time after the explosions. If new pieces of rich neutron matter shrapnel are continuously fed to the same place, magma pressure at such places will steadily increase until it reaches certain limits, called upper limits of magma pressure. If the space in which high-pressure magma occur is below a thick layer of lithosphere, there will be no immediate consequence occurring there because the thick layer of lithosphere can ward off the impact of high-pressure magma below it. However, if such high-pressure magma occurs under vulnerable places like the boundaries of tectonic plates or volcanoes, there may be either earthquakes or volcano eruptions or both to occur. This video clip describes how energy produced by the conversion from rich neutron matter to poor neutron matter below a volcano causes the volcano eruption. In this video clip, it takes 5 rich neutron matter explosions to bring magma pressure to the limit at which the volcano starts to erupt. Similarly, if the upper limits of magma pressure occur right below the boundaries of tectonic plates, earthquakes may occur there. This video clip describes how energy produced by the conversion from rich neutron matter to poor neutron matter below a point of a boundary of tectonic plate causes an earthquake. In this example, it takes 5 explosions to produce enough energy and bring magma pressure to the limit at which the earthquakes start to occur. When volcano eruptions and earthquakes occur, magma pressure starts to decrease, but high-pressure magma can remain for several days. That is why earthquakes, including aftershocks, and volcano eruptions can last for several days. After the magma pressure has reached the lower limits of magma pressure, such volcano eruptions and earthquakes stop. In order for the next volcano eruptions or earthquakes to occur, magma pressure must be built up again, and this process, the buildup of magma pressure, may take a lot of time, maybe centuries, to reach magma pressure upper limits. In summary, the direct cause of both volcano eruptions and earthquakes is because the magma pressure right below the volcanoes and tectonic plate boundaries has reached the upper limits, and the increase in magma pressure is caused by the explosions of pieces of rich neutron matter shrapnel, which are originally formed at the core of the Earth, then move towards the lithosphere due to the 3 factors: the solar repulsion field, the rotation of the Earth around its own axis, and the terrestrial repulsion field. So how about El Nino and La Nina? Besides the continuous creation of pieces of rich neutron matter shrapnel that cause either earthquakes or volcano eruptions, as previously explained in the first part of this video, the mass of the body of terrestrial rich neutron matter at the center of the Earth also undergoes big fluctuation in mass. That means the mass of the body of terrestrial rich neutron matter grows and then shrinks alternately. When the mass of the body of terrestrial rich neutron matter reaches the upper limits, the terrestrial repulsion field produced by itself is strong enough to break a child body of terrestrial rich neutron matter off the mother body of terrestrial rich neutron matter. This child body of terrestrial rich neutron matter leaves the mother body of rich neutron matter, moves close to the lithosphere in the similar way to how pieces of rich neutron matter shrapnel do. When this child body of rich neutron matter comes close to the lithosphere, it explodes, converts into poor neutron matter, and releases massive amounts of energy. If such massive explosions occur below Pacific Ocean seabed, this massive amount of energy will heat up the entire Pacific Ocean. The heated seawater of Pacific Ocean will move along the Earth's equator, from the west part to the east part, thanks to the equatorial countercurrent, then heat up the east part of Pacific Ocean, especially the sea zones to the west of South America and Central America. This is El Niño phase, the phase in which seawater temperature in the east part of Pacific Ocean is hotter than the normal temperature. After the seawater temperature in the east part of Pacific Ocean has peaked, it then has to cool down because of the limit of the amount of heat energy produced by the explosion of the child body of rich neutron matter. When Pacific Ocean cools down, sea zones to the west of South America and Central America also cool down. If the temperatures of sea zones to the west of South America and Central America are low enough, Pacific Ocean will be in La Niña phase. In summary, El Niño phase is caused by the massive explosion of a child body of rich neutron matter below the seabed of Pacific Ocean, and La Niña phase is caused by the absence of such massive explosions for a long time, usually from 2 years to 7 years. In other words, La Niña phase is caused by the slow conversion from rich neutron matter to poor neutron matter below the seabed of Pacific Ocean, and that results in the cooler Pacific Ocean. If such massive explosion recurs, the temperature of seawater of Pacific will rise and the Earth will start to undergo another El Niño phase. In the development of El Niño phase and La Niña phase, the equatorial countercurrent also plays a considerable role. This ocean current brings either hot seawater or cold seawater to the east part of Pacific Ocean. Such hot seawater or cold seawater leads to El Niño phase or La Niña phase, respectively. Another important conclusion is that without the solar repulsion field, the body of terrestrial rich neutron matter is completely a sphere. There will be no chance for terrestrial rich neutron matter to convert into poor neutron matter. So, there will be no explosion of terrestrial rich neutron matter. Therefore, there will be no earthquake, nor volcano eruption, nor El Niño, nor La Niña. Thank you for watching.